Let me show our presentation in which we would like to emphasize rock pressure relief as the basic alternative for sustainable underground mining of tabulated deposits. First, we will describe the conventional retreat longwall technology because it's the most efficient, reliable, and safe. We will show that the maintenance of the tailgate to the longwall face is a crucial link of this technology, which restrains the successful realization of the retreat system, especially at the deep horizons. Then we substantiated a new location for a longwall tailgate and developed a new layout and technology of driving and maintenance of a roadway in a caved and consolidated rocks of the compressed goaf, shortly D&MRCR. Next, we will describe the results of industrial testing and discuss the parameters of the new technology. Finally, we will demonstrate why the new technology provides sustainability of underground coal mining. Most of the underground coal has been extracted with the retreat system. To prepare coal for extraction, practitioners develop at least 2 head entries or head gates and a minimum of 2 tailgates. This provides outlining of a big long portion of a coal seam named panel and allows exploring this portion in detail that minimizes possible geological risks during the extraction. The panel has retreated with a longwall, which must be ventilated with fresh air for safety. There are 2 possible options. The fresh air is input from the head entry, washes the longwall face, then a mixture of the air, methane, carbon dioxide, and sometimes even the most dangerous carbon oxide is removed to the tailgate, going along it conduently in the same direction. This is a direct option of ventilation, which allows pressing back the dangerous gases from the longwall. The other option is the return one, which is riskier and less efficient because provides the output of the coal 1.5–2 times less. That is why the miners try to apply direct ventilation as much as possible, but the tailgate should be maintained behind the longwall. That is a big challenge. Roof subsidence in this tailgate may reach up to 1 meter, and floor heaves 2 meters and more. Aggressive underground water softens the surrounding rocks. Intensive ground pressure builds-up inevitably and inexorably because of the reserves depletion and steady increase of the mining depth. The head and tail gates are separated with so-called chain pillars. But the steady growth of the mining depth forces to increase the width of these pillars up to 90 meters and more, whereas the total size of the chain pillars may be as small as 15 meters at the depth of 200 to 150 meters. Therefore, the main challenge is how to make available the direct ventilation for the retreat longwall, providing good stability of the tail entry behind the longwall face. The chain pillars with width of 100 meters become unacceptable. Artificial bearing support made of cement and sand mixtures is the only mean which has been tested recently to provide maintenance of the tailgates. However, moderate results were reached at the depth which still not exceeded 700 meters. We investigated the irreversible and highly nonlinear process of ground pressure evolution during pillarless extraction of adjacent panels at the great depth 1000 meters and more. Ground pressure relief occurs in the caved rock, or a gob, created by the extraction of the current panel. Warm color indicates relief, and numbers show the sequence of the extraction. The previously extracted panels accumulate the stress, hence their goafs are not appropriate for the allocation of entries, which lose their stability after extraction of adjacent panels. Cold collars specify high ground pressure zones. We determined that the tail entry should be driven along the stress relief zone, that is at the distance 30–40 meters from the lateral boundary of the current goafs. Face of the tail entry should be lagged behind the moving longwall by 150–300 meters, depending on the rate of the longwall retreating. Such a location provides good stability of the roadway. Unfortunately, as I've just told, extraction of the adjacent panel annihilates the stress relief zone in the previously created goaf, and the roadway loses its stability. Unit 01 corresponds to the virgin level of the ground pressure. We may see that the tailgate can maintain perfect stability, because the stress level in the surrounding rock mass in the current goaf is less than by order than the virgin level. However, the stress jumps above the indicated by intermediate line critical level after extraction of the next or adjacent panel. Therefore, we developed an extra measure to protect the tail entry with a special body of waste rock that should be erected between the tailgate and the boundary of the current goaf. The waste rock is taken from the tail entry driving and replaced by conveyor and pneumatic transport to position 12, that is immediately behind the longwall. The tailgate face is ventilated by a local fan, which takes the fresh air in front of the longwall and pushes this air into the tail entry face. The next slide demonstrates as the tailgate 9B is driving in the scaved and compacted rock or consolidated goaf, whereas gate 9, being protected from the negative impact of the current panel by the body of the waste rock, may be reused to serve the activity in the currently operating longwall. Diagrams on the next slide demonstrate that the body of the waste rock protects the reused tail entry properly. The blue diagram shows stress distribution before extraction of the adjacent panel and the yellow curve after. The increment of the ground pressure around the reused tailgate is not essential. D&MRCR technology has been tested at the coal mine in Donbass, Donetsk city, Ukraine. Experimental crosscut number 3 has been driven in the compacted goaf of the first east panel at the depth of 820 meters. This crosscut was oriented normally to the boundary, but it was even better because one crosscut helped to investigate the negative effect of the adjacent third east panel extraction at a different distance from the boundary. Crosscut number 3 was separated from the boundary with the body of the waste rock. Next slide demonstrates that this body has protected the crosscut reliably. Convergence of the roof and floor in the roadway did not go beyond 150 millimeters at the monitoring station 7 and 8, whereas the convergence in the body range exceeded 1 meter. New D&MRCR technology has been proposed for the extraction of coal at the depth of 1025 meters in a modern coal mine. We accommodated the parameters of this technology for such hard geological conditions. Stress relief in a current goaf almost does not depend on the depth of mining. This is extraordinarily important and prospective for the maintenance of the roadway at any depth. In addition, the waste rock taken from the entry driving is used to erect the protecting body that is friendly from the environmental point of view. Conveyor and pneumatic transportation of the waste rock are extremely simple and reliable. This minimizes possible risk and confirms the sustainability of D&MRCR technology. Thank you for your attention.